Welcome. This problem asks for the volume of a pentahedron, a solid with exactly 5 faces. The base is a 13 by 8 rectangle. The top is not a face but a single edge of length 7, running parallel to the 13 unit sides of the base, and centered over it. This shape is sometimes called a wedge or roof solid. The 5 faces are 1 rectangular base, 2 triangular end faces, and 2 trapezoidal side faces. Let's look at each face in detail. The 2 triangular end faces are isosceles triangles with base 8 and both equal sides of length 13. The 2 trapezoidal side faces are isosceles trapezoids with parallel bases of 13 and 7, and non-parallel legs of 13. Notice that all the slant edges have length 13, the same as the base length. This symmetry will help us find the height. Let's find the height of the solid. The top edge T1 T2 of length 7 is centered over the base, so each end is offset 3 units inward from the base corners. The slant edge from base corner O1 to ridge point T1 has length 13. Horizontally, T1 is 3 units in the x direction and 4 units in the y direction from O1. So the horizontal distance is square root of 3 squared plus 4 squared, which equals 5. Then by Pythagoras, height squared equals 13 squared minus 5 squared, which gives 169 minus 25 equals 144. So height h equals 12. Here is the full question. The base is a 13 by 8 rectangle. The lateral faces are 2 isosceles triangles with base 8 and sides 13, and 2 isosceles trapezoids with bases 13 and 7 and legs 13. What is the volume of this pentahedron? The choices are A. 416, B. 520, C. 528, D. 676, E. 832. Let's solve this step by step. Step 1. Confirm the height is 12. The ridge T1 T2 has length 7 and sits above the center of the base. Each ridge endpoint is 3 units in from the 13 unit side and 4 units in from the 8 unit side. The slant edge from base corner O1 to ridge point T1 has horizontal component square root of 3 squared plus 4 squared equals 5, and total length 13. So the vertical height is square root of 13 squared minus 5 squared equals 12. Step 2. Split the pentahedron into 3 pieces. The key idea is to drop vertical planes through the 2 ridge endpoints T1 and T2 down to the base. T1 is 3 units from the left end. T2 is 3 units from the right end. This splits the solid into 1 central triangular prism of width 7, and 2 identical pyramids on the left and right, each with a 3 by 8 rectangular base and height 12. Step 3. Volume of the central triangular prism. The prism has a triangular cross-section. The triangle has base 8 and height 12. The full height of the solid. The prism extends for a length of 7 along the ridge direction. Volume of a prism equals cross-sectional area times length. Area of triangle equals 1/2 times base times height equals 1/2 times 8 times 12 equals 48. So volume of prism equals 48 times 7 equals 336. Step 4. Volume of each pyramid. Each end pyramid has a rectangular base of 3 by 8 and an apex at the ridge point T1 or T2 at height 12. Volume of a pyramid equals 1/3 times base area times height. Base area equals 3 times 8 equals 24. So volume equals 1/3 times 24 times 12 equals 96. There are 2 such pyramids, contributing 192 in total. Step 5. Add up all three volumes. The central prism contributes 336. Each pyramid contributes 96. And there are two of them, giving 192. Total volume equals 336 plus 192 equals 528. The answer is C. The volume of the pentahedron is 528, which is answer choice C.